So we will design a parking lot. So in parking lot, we'll see how we will how what are the different requirements of the system. Okay, what are different systems we require. Then we'll see what are the different system and how what CRUD operations we need for each system, like for admin, for customer point of view, for parking attendance, for system. So what are the CRUD operations we need for each of them. Then we'll go through the now we'll make the classes out of this, and then we will define a relationship and we'll show them using UML diagram, right? These are the UML diagram. And then we'll go through activity diagrams. So a particular use case we'll take, and then we'll draw what are the different steps to achieve this. And then the we'll go in the end we'll go to the code part of it. Okay, so what we see here in system requirements is the parking lot should have multiple floors. So where customer can park their cars. Okay, so it should have multiple entry and exit points. So customer can have one of the multiple entry and can exit from one of the exit points, right? And then the customer can pay at the exit point, right? Or they can pay to the parking attendants. So the place where customer place their vehicle, at that place the parking attendants will be there. So customer can pay to the parking attendants, and if they have paid already to parking attendants, they don't need to pay at the exit points. Okay, so now the thing is, customer while paying, how they will pay? They can pay through cash or credit card, right? Okay, now there can be a thing like we the whole parking slot is filled, right? So we should have a count or monitor to check the counting of slots. So and if it is full, then we should show a message to the customer, right? So the system basically will show a message to the at the entrance panel itself when the parking is full, right? Now each floor will have different arrangements for different type of vehicles. So each floor will have different spots where the vehicle will reside. And this parking spot is of different types. So compact, where only car can be parked. In large, car as well as truck can be parked. So large, and then handicapped, and then motorcycle, where only motorcycle can be parked, right? So we have what we see is we have different types of parking spots at a particular floor. And then the parking lot, we have the facility for electric cars also. Okay, so this is going into deep. We have a special case for electric cars. So there will be some spots for electric cars only, where the customer can pay and charge their vehicles, right? And the systems to support for different type of vehicles, right? Car, truck, van, motorcycle. And then each floor should have a display board, right? Like what are the you know on that floor, what is the spot which is vacant, okay, which is free. If it is not free, then the message will be displayed. And then there will be a rating model. Okay, so per hour parking free model will be there. Like the customer will have to pay $4 for the first hour, and then for the second hour they have to pay a bit less. For the remaining hours they have to pay further less. So this is the model we can have it. So from this was our system requirement. From this requirement we see the use cases. So what are the different, basically the actors? So actors is basically uh, who does the work, right? So admin who is doing the work, customer is there. So who is the moving part basically? So parking attendant is there, right? So admin is basically what the role they will do. So uh, they will add or remove the parking floors, they can even parking. So within each floor they can add or remove spots entrance, they can add or remove multiple entrance. Similarly for exit panels, similarly for parking attendants, what the customer will do, customer will uh, generally will pay the parking ticket, right? And the parking attendants are there, okay, to help customer for if when their customer are going to pay. So they are for that. Now system is basically to check whether if the parking floor does not has any space, they will just say like there is no space, or they will assign a, remove a vehicle from a parking spot. So yeah, these are the use cases of a parking lot. Okay, so basically these are the CRUD operations, right? So we are adding, removing parking floor, these are done by, you see, admin here. For same for parking spot, parking attendant, take ticket. So basically take tickets, parking attendants will take ticket, right? Then they will can scan the ticket. Credit card payment, the customer, the parking attendant can have the credit card payment. Cash payment, the customer can choose the cash or the credit card payment, right? Add or removing parking rate. So I think this is also done by admin, right? And here we have the use case diagram. So we can see the admin, basically they have this functionality, right? They can add, remove parking rate. And when you need to add parking floor, after you are done with adding parking floor, you need to also add a display board, where, right? Yeah, similarly for parking spot, so you need to have add one electric panel also, so that electric vehicles can also be able to will be able to park, right? And what does the parking attendant does? It just, you know it can log in into its own account and see account and update account. And the customer can, so the customer basically pay the tickets, right? Okay, we have the system which assign a parking spot to a vehicle, then removing from a spot, right? And sending the full message showing available parking spot message. These are the works of a vehicle. Now comes the class diagram. So let's see the UML diagrams. So in the case of UML diagram, we will just go through what are the different this UML diagrams, so that it's easy to catch up. So we see here, okay, so this is you will see in the class diagram of educative. So here you see is first we'll go through association. So association in general is bidirectional. So like for example is like flight instance, and take the pilot instance. Okay, so pilot, so flight instance know of pilot, and pilot know of okay, like flight instance exists, right? So so this is the simplest, the class just know each other, and there is nothing like if this class doesn't exist, then this will not exist. It's a very simple relationship, just like this. And we see here this star and two. So basically this means like uh, you know each instance of a class will have can have maximum of two pilot, right? So a flight is there, right? Flight, how many people can pilot will be there? There can be maximum two people. But a pilot, they can have a n number of, they can go to a n number of flight, right? So that's what is star representing. And you see here, this is a simple arrow, simple line, right? So solid line. So this what is represented as association. Now uh, special case of association is so association is bidirectional. In the case, so special case of association is unidirectional. So in this case, aircraft, so flight knows about aircraft, right? So if you see here, okay, when we talked about, so flight class knows about aircraft, right? uh, the flight aircraft really doesn't need to know about flight, right? So that's why it is pointed as unidirectional. And it's uh, case of association only, right? Now we see uh, aggregation. We see aggregation. So aggregation is, you see here, diamond shape operator, diamond shape, this thing. So this is which is not solid. Okay, so this is basically a sign of SOC, aggregation. So aggregation is uh, you know is also a special type of association. Okay, and the thing is uh, this, so aircraft has, aircraft, so airline has aircraft, right? But the existence, if airline, even though airline doesn't exist, which is, you can take as airline is parent, and aircraft is something like a child. So child is, so aircraft is inside airline, right? So even though airline is doesn't exist, aircraft can exist, right? So that's why it's shown as a aggregation. Whereas in the case of composition, so whereas in the case of composition, okay, which is also a special type of aggregation, okay, another form of aggregation, okay. So you see here diamond, right, and which is marked as solid, right? So you see here, if this is a parent, right, and these are the child. So if the flight doesn't exist, it doesn't make sense that the weekly schedule and the customer schedule be existing, because whom does this weekly schedule means to? Flight only, right? So that's why, if we remove instance of flight, then automatically, this child component will get removed, classes will get removed, right? So that's the importance of this uh, composition. Okay, so uh, here in this diagram, okay, let me tell you that basically this inheritance is generalization only. Okay, so if A inherits from B, so if the relation is only just like A is extending, extends B, right? In the normal Java world, so that is a basically inheritance or generalization. Whereas you see the dot, this notation, so basically this is for A is implementing B. So B is basically an interface. So this is not generalization. I think by mistake it's there. If you see here, okay, so this is class diagram from Wikipedia. So that is basically realization and implementation. You can see here we have marked at like this. So so basically this is realization or implementation. Okay, so A implements B. So in the case when you know so we have some inheritance, some in the case when we have interface, and then a class is extending, a class is implementing interface, then that is, we can denote by this, okay, diagram. Now abstract class we can have written in italic, and the normal class we can have it as a normal word, right? So that was about UML diagram. Okay, so we come here. Okay, so we see here basically the system needs parking lot, right? Now the system needs, we need to create the class for it. So when we create the class for it, we need to make sure that we have only one object of it, right? So we'll create singleton of this class. Now the admin will always access the singleton and of this parking lot, and then what it will do, it can create multiple entrance, it can create multiple exit, it can remove also. So that's the work of admin, right, which is this here. So what does admin do? So it will just get the instance of parking lot, which is single instance, and then what it will do, it can call the parking floor, add parking floor, and then it will add the parking floor. So you see here, this is composition composition, right? You see here, this is composition relationship, right? So parking floor will not exist without parking lot. So all the creation of parking floor happens in parking lot, right? So similarly for entrance, okay, we can add entrance panel, exit panel. We can also add parking attendants, and then we will be able to only add floor and whatever is when the parking lot is not full, then in that case only, right? Parking lot will have the address, will have the name of it, okay, to distinguish it from other parking. And then parking rate will be there, okay, so at what rate we will charge the customer. So we see here this is dependent on this. Similarly exit entry, this was of parking lot. And when we see here parking floor, okay, now comes the parking floor. So what are the components which comprises parking floor? So parking floor will have display board, right? So if we don't have parking floor, it doesn't make sense to have display board also. So that's why the association is, the association is here composition, right? Composition. Now similarly for parking spot, uh, there can be n number of parking spots, so it has association property. The customer info portal also, right? And now we can, in the case of parking spot, we have different types of parking spot: handicapped, compact, large, motorbike, and electric spot, right? So these extends, parking spot, so there is inheritance relationship. Now this vehicle, okay, so vehicle also has different types like car, truck, electric van, motorbike, which extends this vehicle. So so this is it. And uh, whenever, now the admin, there are two accounts like admin and the parking attendants, which extends this account. And what does parking attendants do is like, they this when any new customer comes at the entrance, they can ask the parking lot, okay, create a new ticket, right? And once you have created the ticket, let the vehicle know which ticket has been assigned. So the vehicle has parking ticket. So you see, this is unidirectional. So vehicle knows which ticket it has associated to. Ticket doesn't need to know like whom which vehicle I am connected to. Vehicle is just needs to know the ticket, right? Similarly in parking spot knows like for I am the spot, and now which vehicle I am associated to. So this has the has relationship. And the payment is there, like there are two different types of payment: cash or credit card, and these are inheriting from payment, right? And then we have electric panel, which is electric spot, which is connected to, and then there is payment, right? And we see here, okay, we need to define some constant. So we need to what can be the constant? We know the parking spot type. So basically in Java enumeration, we define these constant: handicap, compact, large. Vehicle type is car, truck, electric van. And this status, has it is it active, has it been paid, or is it lost, okay? Account status, okay, for the customer, okay, is it active, is it closed, cancelled, blacklisted, null. And the location for this parking lot, right? We need to know the street address, city, okay, state, zip code. And then the person, the customer, right? The name, address, email, and the phone number of his. So we see here, these are the constant and these are the data types, right? So yeah, so we are good with it now. Basically we'll go through the code. Just one thing I want to tell you, this activity diagrams. So we have this use case, right? So the use case is like customer have to pay the parking ticket. So how the flowchart is designed is like, when the customer inserts a parking ticket at the exit panel, so when he has already parked his uh, parked his vehicle, and now he is going out of exit panel. So then what he does, he doesn't he simply needs to check if he has already paid. Okay, he gets the entry exit, otherwise he has to pay it, right? So if ticket is already paid, he just get the exit, he just get the exit through the gate. But if he doesn't, the system calculates the what is the parking fee, and then uh, and then subsequently the payment happens. And the payment, the thing is, here we have to check the action where it is yes or no, right? So accordingly we need to change the direction, right? So here we see it's a just sequential process, right? But here the decision we have to take, whether successful, payment successful. If yes, then we just print the receipt and we show customer the exit gate. If no, then we can again try it, and yeah, and then yeah, that's all, right? Now that we when we come to the code part, okay, we see here we define the in enum the vehicle type, we define the parking spot type, handicap, compact, large. So these are for spot, right? Now, okay, now count status. Okay, is it been blocked, or is it been, this one? Parking ticket status, active, lost, paid, has the, it been paid or not, address, and then the person, right? Okay, so what we'll do, we'll just first go through parking lot, because that's the core class where everything starts. So parking lot, yeah, we'll try to enforce singleton. So enforcing singleton is okay. Okay, so parking lot will have name, will have location, and will have the rate. Okay. Now we need to what does parking lot does is, uh, it also has, what are the uh, s- compact spot count, as why is it so? Because it needs to track if it is full or not. If that particular spot is full, then it should display the message, right? It is full, and the the admin is not able, can't actually add more uh, you know spot, add more, assign the vehicle to a spot, right? So that's why this class needs to know this, needs to have this information. And we have the maximum, which is we have made as constant, like we cannot have maximum, we cannot have means the system cannot have more than this electric count, right? And yeah, so for electric panels, exit panels, and parking floors, we can put it in hash map, because we need to know, the name also of it, right? And then the exit panel as an string is as a class, right? And then active tickets, right? The name of ticket, and then the parking ticket. Now it comes the parking lot. Now we have defined the object as null. Okay, what we do as in constructor, basically we initialize the from the db, okay, all the name and address and parking rate, we initialize all these things from the db, and then subsequently these datas from the db, and then these datas from the db. So you see here, then initialize the parking floor, and then then initialize the counts of all the active tickets, and then the entrance and exit panels from the db. So whatever is we defined it here, we initialized in the constructor. Now whenever the uh, admin will make an instance or call to this class, so what it will do, this function will check, do we have this object already initialized? If not, then initialize a new object, otherwise just pass the remaining object. So this is how instance singleton is you know singleton is created, right, using static. This is very important, right? Only so this object belongs to the class only, right? So yeah, so when it comes to now adding parking ticket, so the admin will call this function, ki like, okay, this is the vehicle, and you and create a ticket, and then assign that ticket to vehicle. Okay, so the vehicle knows like I am attached to this ticket. So what it does, so now it checks is full. So it wants to know, okay, if this vehicle type, if it is already full, then it will just throw the exception, right? So if you see the full, okay, what it does, it just checks whether the vehicle type is truck or van. In that case, only it returns true. Okay, when the so if it is truck, so that will stay in large spot, right? And if it is vehicle, it will stay in large spot. And if its counts is like reach to the maximum level, at least reach to the maximum count, then we are done with it. We can't actually allow the system to hold more of truck or van, right? So that's what we check it. And then in the case of motorbike, we check the motorbike count. If it is more than the maximum, we are done, we can't allow more than that. If it is less, then fine. Now car, since the car can fit in either in spot or in large, so we just check, okay, uh, you know if the value is this is more than this, then we are done with it, right? So in the case of electric car, so we are just checking electric car can be fit in compact, large, and electric, also electric. And then we are checking if it is more than the maximum, then we are done with it, right? So if any if the sum is basically less than the maximum, then we know like at least there can be either compact or large, where this car can fit in, right? Okay, so we were here. So after we see key, we are able to have free space. So what we can do, we can create a ticket, and then this ticket knows, okay, then we assign the ticket to vehicle, and then we save into DB, right? So this ticket we assign to vehicle, so that's what we see here. Okay, this ticket we assign, assigned to vehicle, so that's why vehicle has a relationship to ticket. So ticket doesn't know anything about vehicle, but vehicle knows about ticket. Okay, so let's come here. Yeah, and then after we are done, we will increase the spot count for that vehicle type, right? So that you know so suppose this is truck, so next time the large will increase, right? So this increased spot count will actually check the type. If it is truck or van, it will increase the large spot count. If it is motorbike, it will increase the motor spot count. If it is car, now, if it is car, basically we will try to check this compact, because uh, compact is really made for car. Okay, so we'll need to give first preference to check if it is compact is free, we'll try to adjust car into it. So we could have adjusted large also, but since large is can be utilized for truck or here, like bus, so we should only take as that as a second option when we don't have compact. So that's why we checked here, and then we increase it here. If it is compact has filled up, then in that case the large, we increase the large. In the case of electric vehicle, what is our first preference? That you should electric vehicle first should fit in electric spot. If it doesn't has electric spot, then we can go for compact, and then in the end we can go for large. So we went to large because here other vehicles like many other vehicles is able to fit in, right? So that's why we don't want to disturb, or we don't want to you know take this into priority. First, whatever is the, we take the priority which has less number of accommodation. For like this only has can accommodate electric cars only. This can only accommodate electric only cars, right? So that's how it goes. Okay. Yeah. Yeah, so now in the active tickets, we get the ticket number and then the ticket, right? And then we are just returning the tickets. Okay, so this was our all about like parking lot. Now we will see, yeah, now we'll see how, now that we'll see the account. Now the what was the account? We'll have the username, password, and reset password, the normal process, the normal things. Now the account, we have admin and we have parking attendants, which is extending account. So we'll see here. So we have admin and we have parking, which is extending account, right? So okay, so what does this admin does? It has the ability to add parking floor, so it will get the instance of a parking lot. Okay, so it will do, it will get the instance of this parking lot, the singleton one, and then it will add the floor. Ask the singleton, okay, just add the floor or add the parking spot or add the entrance panel, exit panel, right? And yeah, booking attendants will process the ticket, right? So and now we'll see the parking spot. So in parking spot uh, is made for handicapped spot and compact spot and large spot, okay, motorbike spot, electric spot. So these are extending from parking spot, right? And then so that's why they are extending it, right? And what we are doing here, we need to have one assigned vehicle. So you remember while we are creating ticket, so we were assigning uh, so we were assigning vehicle to spot, right? You see here. So basically we are ticket to spot. Okay, so similarly we need where it is, yeah. So for spot we need, okay, like vehicle will be assigned to spot. So that's why you see here, okay, spot. So it has vehicle. So spot knows which vehicle I am assigned to. Okay, so yeah, so this was it. And when we have to remove vehicle, just we vehicle we pass it to null, and we there is a free instance, so we assign it to true in the case we have removed it. So that means now this spot is free, we can we can add any other vehicle in future. So those are the required functions and properties. Now we come to vehicle. So in vehicle we need assigned ticket, right? So this was which was being called in the while in the um parking lot, right? So we assign the ticket to this vehicle. And yeah, we have the car, we have the van and truck, which are extending the vehicle. And then we have the type, we have the parking ticket, license number, right, the required data. When it comes to parking floor, this is very important. Parking floor, so in parking floor we have the name. So parking floor knows, okay, what are the different spots for handicap, for compact, for large, right? So parking floor will have the information of all these spots, right? And then it will have the display board. Now now what happens is, if we need to add parking spot, okay, what it will do, the spot will check the type of it, and accordingly, so spot is like, okay, suppose it is compact, okay, and what we will do, for that particular floor, we will in the compact spots we will add the key as the number of spot and the object itself, right? And yeah, so that's why so we can add the spot to a particular floor, okay, using this method, okay. And then we can assign vehicle to spot, right? So when we are calling this function, So vehicle get assigned to spot. So this assigned vehicle, so this is what we were when we were here. Okay, assign vehicle to a spot. So this is being assigned, vehicle being assigned to spot from floor, right? So we did assign it, but after we have assigned it, we have to make sure that we have to update the display board, right? So the parking floor is there, we have assigned the vehicle to a spot. Now display board should tell you, right? Okay, now, okay, we are done with this. Now which one is free, right? So similarly for compact, similarly for this, now we see, for example, for compact. Okay, so when we see what happens with update display board for compact, what it does is, so the display board, okay, so display board is basically another class. So so each floor will have a instance of a display board, right? So we'll see here, okay, we have the display board, right, in parking floor. So so what it does, it checks, okay, the free spot. Okay, now if it matches with the, the spot number, yeah, then what we do, then it's fine, right? So that spot was free, and for this particular floor, okay, uh, this particular floor, okay, on the dashboard it says like, okay, yeah, so this spot is also, so this spot is known by the display board key, like, okay, I am also free. So when it knows that, what it does next, it loops around all the compact spot. Okay, now it checks which spot is free. Okay, okay, now what it does, when it knows any spot is free, now what it does, it sets the compact free spot. So at this key, okay, what it does, it just adds the particular spot to as a free spot. So what happens is, okay, next time whenever any request for compact spot comes, okay, so you know so this particular so whoever is free, whoever we added, will assign, right? So so basically this spot, okay, is different from whatever we are adding it right now. So this spot was free. Now we have already occupied it. Now we need to know what is our next free spot, right? So that's why we, looked around this compact spot. We came to know, okay, this key, okay, for this key at this compact spot is free, and then we are adding to it. Okay, and then in the end, the display board is showing the whatever the empty compact number is there, so that the system knows, okay, this is the empty number. So the next time when they assign it, they assign only that empty, empty number, right? Empty spot. And again it comes here, and then it, this, since this spot is now filled, and now it will check for any empty, right? So yeah, so it goes like this. When we see the parking display board, okay, so it has a function, like it shows you uh, in the end, right, which spot is free, and it gives you the number of it. If it is filled, okay, if it is filled, if there is no free spot, then it just tell you that that particular spot is filled, and then it just concatenates the message, and in the end just show the message. Okay, so yeah, so that was all about like object design questions, okay, for a parking lot.